Hey Faris, so thanks for the question, mate. So for part A here, I've just defined the two vectors. Column notation works here, or alternatively, if you like, I and J is better. Feel free to do that as well. Yeah, so for us to find y O to P, so P is some point on this line, AB, why that equals this expression here. And we can do that a couple of ways, but how I want about it is, firstly, we've got to define that A to B is final minus initial, so that's B minus A. So we could calculate that in numbers, but for part A, it actually wants us to keep it in this form, so I'm going to leave it like that. Cool. It then tells us that OP is just some point here on this line. We don't know where, so I've just put it arbitrarily there. I feel like if I was going to draw this, I wouldn't put it precisely in the middle, because I don't want myself kind of being convinced it's the midpoint. It's just some value along that point. It could be here, it could be there even, right? Okay, but OP, if we want to go O to P, how we could do that is by indirectly going O to A and then A to P. See that? So I'm going to define it like that. We know that O to A is obviously vector A. So it's up there. And A to P here is the same directional vector as A to B, but it's some scalar multiple. And so the reason I've written it as one on K to start with is because it's a scalar multiple that's obviously less than 1. So it's some fraction of this line, which could be shown as 1 on K. But it doesn't really matter whether it's 1 on K or just some other constant here, because all we need to show is that it's some constant multiple. And so T works fine. Like you could have T equals 1 on 4 or something, right? Like, that's fine. So we're just going to say that T is our scalar constant outside of this line A to B. And we know from up here that A to B is vector B minus vector A. So we've just got vector A plus T outside of B minus A, which should give us the expression that they're asking for in part 1. Alright, so the second part was definitely a lot more difficult, but let's run through it. Okay, so the first main thing I was doing here was using this application, the dot product from the filling machine. And so this includes an angle, and the angle is the angle between the two vectors here. So using that, we know that our angle is 60, and so we'll only have one unknown here, and it should be T. We just got to do some manipulation here to get our value. So from the first part, we got that P equaled this, but this isn't really a nice number. But we can evaluate it, right? We've got A and we've got B. So that's what I did up here. So we said that P was A plus T outside of B minus A. B minus A, we can work out to just be 3, negative 3. Awesome. So then, obviously get 3T, negative 3T. I just combine these into one vector. This one vector equals P. Awesome. So, A dot P is going to look like A dotted with P. So that's what we have just here. And then on the right hand side, obviously we know the magnitude of a vector is square root of A squared plus B squared, or like whatever, like I squared plus J squared, that kind of thing, right? So from that, this is just 1, 1, so 1 squared plus 1 squared is just 2. And then square root 2 we're just going to write as root 2. Awesome. So this one's a little bit more tricky. So this is actually our x coordinate, this is our y coordinate, so we have to fully square both of these. So square this and square this. And that leaves us with some more interesting expanding out. So remembering here, when you're expanding something with addition or subtraction in the brackets, and we're squaring it, you've got to remember, yes, it's the first term squared and the last term squared, but you've got to also remember that it's the 2ab term in the middle. So 2 times a times b, so it's going to be 6t in the middle. So this is what you get for the first one. And then for the second one, even though there's a negative here, the negative still goes to positive 9 when it's squared. And then so this is what you get for the second guy here. And cos 60, if we go to our special triangle here, cos 60 is just 1 over 2. Awesome. So with that all simplified, the next step I did was do the dot product here. So the dot product is a1 times b1 plus a2 times b2. So essentially we're just adding these two, which is going to cancel these and add these together. So we get 2 overall here. Over on the right hand side, the only thing I did at this step was collect like terms. So these two come together, these two cancel, and this goes to 2. Yeah. So when we get to this step, this is maybe a more difficult one to see. So I took out here a common factor of 2 from these two, which left us with this inside the brackets. And here it's not so simple how to go ahead. But what you need to recognize here is that we can get rid of this root 2 by forming another root 2 underneath here. And because they're multiplied together, we can separate out the root into an individual root here and an individual root here, right? So that's exactly what I've done. And so root 2 times root 2 here is just 2. So these form 2. We've got a 2 on the denominator here, so they just cancel, and I'm just going to be left with 1, right? So my right-hand side is essentially just this. And obviously, what they want us to get is 3t squared minus 1 equals 0. It can still be kind of murky where we get that from, like from this equation. So I just went ahead and solved it for t. And so squared both sides here. Squaring this side gives you 4. Squaring this side gets rid of the square root, so you get 9t squared plus 1. Pretty simple from here. I'm moving the 1 to the other side, and then dividing by 9. So, and then 3 divided by 9 is just a third. So I get t squared is a third. I could go, okay, well t is plus minus root a third. But this is all we need here, because then t squared, if we multiply both sides by 3 here, we get 3t squared equals 1. And then we can subtract 1 from both sides, and we will get the expression that they were looking for over here. So hopefully that will make sense. And now on to part C. Alright, and here's part C. So part C, half the battle is just interpreting what's going on here. So we're asked to find 2 points on this line such that both of them have an angle of 60. And at first that doesn't seem to make sense, because I think the line's restricted, like in this domain, which means that only this point that we found before would have 60. But in actual fact, when you find a vector in space, that vector can be moved around like anywhere, right? As long as its direction and magnitude are the same. So theoretically, that vector could also be up here, which gives us the other possible angle of 60 degrees, where a point lies on the line up here. And if we look at this closely, we then would have a 120 degree angle in the middle here, between the two. So if we're dotting these together, the angle between them, so cos theta, is actually cos 120. So that's the first part you need to understand. The second part is, if we go back to this formula, right, from before, we use the two magnitudes combined with the cos of the angle between them. So the two magnitudes we're looking for is the magnitude of OP1, magnitude of OP2. But if we think about that, if they're both on this line and they're both 60 degrees from A and they're equidistant from A, they're actually both going to have the same magnitude. So what we can say is that magnitude OP1 equals magnitude OP2. And we can kind of just visualize this as well. Even though this diagram isn't perfect, they kind of look like they have the same magnitude. And remembering from up here, this magnitude of P, that is the magnitude of OP1. So we can just take this magnitude and multiply by itself. And so when we multiply these two together, we get rid of the square roots, which just gives us what we started with. Cos of 120 is negative cos of 60, so it's negative a half. We then do what we did before, take a 2 outside, cancel them, so we have negative of all of this. I've just multiplied, so there's a negative here and a negative here now because I've multiplied through. And then the final step is remembering from here, we proved that t squared was a third. I'm now going to use this property here. This is going to cancel to negative 3. Negative 3 minus 1, it gives us 4. So I would suggest that the answer here might be negative 4. But let me know what the answers say. And yeah, hope this helps. If you've got any questions, let me know. But thanks, Fraser.